All right, good evening. Tonight we are going to talk in online office hours about binomial distributions. The reason I'm going back to that, if you remember the test average that we had last week was not where I wanted it at. I'm sure it's not where all the students wanted it at. So I'm going to give a quiz on this Wednesday along with a normal quiz. Normals are what we're covering right now. But I'll give a binomial quiz to give some points back to the test. So tonight at the end of the binomial section, if you have any questions on normals, I'll be glad to talk about that. But past that, let's get started and jump right in. All right. So mean variance and standard deviation. Number one, let's talk about this. This is something that now on the quiz you're not going to be able to have a note card like you did on the test. So unfortunately, I'm not going to be able to go back to that. That would be giving a little bit too much away. If you remember from regular discrete probability distributions, to find the mean when we were working with those frequency tables was just to take the summation. Something's too loud here. No, I got it. Just take the summation of the x's times the probability of x's, right? We worked with the calculator. We worked within stat plot to work through a lot of those. Because if you remember, instead of using this, we would use L1 times L2. In other words, use the syntax of the calculator to help us find this. Then we just found the sum at the end. We're going to walk through that a little bit tonight. Your binomial distributions are still using this exact same formula. This is just a shortcut formula. Hey, good evening, Artemis. Thanks for stopping by. The formula that we use for the binomial that we talk about, which is simply that the mean is equal to NP, right? And that the variance is equal to NPQ. That is the same as working with a regular discrete distribution. These are just shortcut formulas. These are ones that you need to be able to work with in order to find the mean and the variance. So this is where I'm starting tonight talking about this. I'm going to walk through the calculator. I'm going to walk through several problems with you. Nothing major, but if you have any questions, I'll take those at any time. This is, again, just a prep for the quiz tomorrow that should help with the test from previous. And then we also have a test on normal, so I'll be glad to take any questions you might have from the problems assigned from last Wednesday night. Okay. Let's see if I've got... Let me switch gears here. Let me switch to a screen where I've got the calculator up. Should be this one. Yes, there we go. Okay, so now I can work with the calculator side by side. I changed the color of the calculator, changed the screen a little bit. I kind of like this a little bit better. Not that it makes a difference, I don't think, but I think this is a little catchier. So let's talk about finding the mean of, like, say, let's do 15. So if you were given one, like number 15, where n equals 124, whoops, and the probability of success for the discrete random variable is 0.26. That stays constant throughout. You are given that it is a binomial. And so, very easy to work with this, but I'm going to work with it a little bit backwards. I'm going to go back to discrete probability distributions and just show you real quick that it's the same thing. We'll go through the calculator. Wow, n's 124. That's a lot. Okay. If we work with it from this, in other words, if we're trying to find the mean of this binomial distribution and we want to find it using the formula, then I just substitute 124 for n and for p 0.26. Whoops, no problem. So I've got 124 times 0.26. So the mean is 32.24. What am I missing some things on the calculator? There it goes. Now if I go back to this and find it this way, I can do that. But I would have to go into the calculator and enter in the possibilities 0 through 124. I'm not going to do that for this particular one. Let's find I'll do it for one. I've got another example where I don't have to put in as many and kind of mess around with the calculator as much. So let's now go for the variance. Now you're going NPQ, which is just going to be 124 times 0.26, which we already know what that is. That's 32.24. Then we're going to multiply that times 0.74, right? 8494. Yeah. So take that and multiply that times 0.74. 23.86 if you're taking it out to two places. So there's your variance, and then right there would be your mean. Okay, for that particular one. Now we could go back to here if we wanted to. I'm going to do another example with that in just a few minutes, one that has, again, just a few smaller numbers because I'm just doing an example with it. You don't have to work with the binomials with that, but I kind of wanted to kick back and discuss that a little bit. So let me squeeze forward. Let's talk about this problem. I can't remember if I worked this one the last time I was in here or not. You are taking a multiple choice quiz that consists of 5 questions. Each question has 4 possible answers, only one of which is correct. To complete the quiz, you randomly guess. That's very important, actually, that you are randomly guessing so that you have the same probability of selecting. There's one right answer out of these 4 choices. You're randomly selecting, so you're like reaching in and pulling out. So you have the same probability of getting any one of these 4 answers. Whereas if you're prepared for the test and taking a multiple choice test, that might be different. The probabilities would not be even across the 4. So to complete the quiz, you randomly guess the answer to each question. Find the probability of guessing exactly 3 answers correctly, at least 3 answers correctly, and less than 3 answers correctly. Again, I cannot remember if I worked through this one, but I'm going to work through it real quick just as a reminder. And I do have the calculator up. Let me clear out so I can use that in a second. I have to first determine what my n is. So I'm reaching 5 questions. So n equals 5. 4 possible answers on each. So probability of success is 0.25. And the probability of not success or failure would be 0.75. Got everything that I need for the moment. To find the probability of guessing exactly 3 answers correctly. Okay. So what's the probability of getting 3 answers correctly? Okay. Well, let's build this table. Okay. Sorry. Let's build this table. So you've got the values for this distribution, and you've got the probabilities. Well, what are the possible values if n equals 5? Well, is there a chance that I could get all 5 of those questions wrong? In the end, yes. How about 1 of them, 2 of them, 3 of them, 4 of them, 5 of them? So randomly selecting the answers on each one of these, I could get any one of those possibilities, 0 to 5. So if I go to my calculator and go second vars, and you'll have to scroll down on yours, but it's right there, binom PDF. And I go, the syntax for this is binom PDF. And I'm just going to put NP because that's going to give me all of my selections for this table. So I'm going to go 5,0.25, enter. Now I've got all of them labeled across. I'm not going to go up and scroll through and pull them out. What I'm going to do is store them, STO, and I'm going to store it to L1. Okay. Then I'll have them all in my table. So then I go to Stat, Edit, and there they are. So for my first one here, and I will just take it to, I'll just go 3 decimal places. Let me double check, make sure that's at the top. So the probability of getting none correct is 237. Of getting 1 correct, 0.395. 0.263. 0.087. 0.014. And the last one is 0.0001. So the probability of me randomly selecting on this test, given 4 answer choices for each, and I'm randomly selecting the answer to each of these 5 questions, probability of me getting all 5 correct is not good. Probability of getting 4 is not good, and so on down the line. It's actually, I have a better probability of getting 1 right. So, okay, so here we are. We built our table, got the pulled the calculator values, pulled it out by the calculator values, and now we're looking for the probability of exactly 3 that I get correct, and that's 0.087. So that was the first one. Now, at least 3 answers correctly. Okay, so if I'm looking for at least 3, then I'm looking for the probability that x is greater than or equal to 3. Okay, well, I would add this and this and this together. Okay, so I would get the probability of 3 plus the probability of 4 plus the probability of 5, which would be second quit. We'll clear that out. 0.087 plus 0.014 plus 0.0001. So I get 0.101. Now I'm going to show you real quick another way to use the calculator to find these. Certainly you could use cumulative, push up to 2, and then just subtract from 1. I mean, there's, again, just like with the normal, there's different ways to skin this cat. But I'm going to show you a little bit different way to do this. So if you go second vars, binomial PDF, n was 5, no change there, comma, and then here I'm going to put second parentheses. It didn't put anything, did it? Comma, second parentheses, and then I'm going to put 3, yeah, there it goes, comma, 4, comma, 5. So you see those different parentheses that I've got in there? And I'm going to go enter. Maybe it's this calculator. Let me check something real quick. That works every time. 5, comma, second, parentheses, 3, comma, 4, comma, 5. Oh. What did I forget to put in there? I forgot to put in the probabilities. So clear all of this out because I just made a major error, but I found it. So I'm going to go to binomial PDF. I'm going to put 5, comma. I forgot to put the probability in there. 0.25. Now, comma, second parentheses, and then I'm looking for 3, 4, 5. 3, comma, 4, comma, 5. It has closed the parentheses for me. I hit enter, and there I've got them. And you see they're separated. So I've got 0.087, which I have on my table. Let's see if it'll allow me to scroll across. It doesn't appear to. So what I'd like to do with these, I'm going to do just like we did before. I'm going to go store, and I'll go second to, I'll store these to L2. There you go. Now when I go into stat, edit, when you go into L2, if you look over there, 0.087, 0.014, 0.0001. If I find the sum of these, second quit, not that, second quit, Clear? And then I want to go second list, scroll over to math, scroll down to sum, and I'm going to go L2, enter, 1035. That's not much different than what we got, 0.1035. That has to do with rounding. So my, in here, stat edit L2, I've got 0.087. That should be 0.088 plus, I got 0.014. That should be 0.015 plus 0.001. You know what? I may have written that. I did write that wrong. So it's 0.104. Yeah. So this is right. Instead of writing 0.001, I wrote 0.0001 in the case of that. So I made an error. That's my error right there. That's human error, just transcribing that down. And then when I go back, anyway, this is the right answer. This is a little off because of this and also because of my rounding. This should be 0.015. This should be 0.088. So it takes it up just a smidgen. So we're going out tens, hundreds, thousands place. It's a little bit different. Okay. Hope everybody sees that. And again, this kind of human error happens all the time. So always double check your work and always do like when you go to the doctor and get a second opinion, so to speak. I did it with the calculator. I got something, and I did it by hand and got something in the calculator, but just piece by piece. And I see that the error of my ways is that 0.001 should be that probability at the end. That's the biggest one. And then 0.088 and 0.015. So, okay, hope this helps. Now, if I want to find the mean of this, let me second quit and clear. And again, the flaw with me using Keynote to write on, I can't just erase stuff out. But I might be able to take a second and undo. That's terrible. Keynote, if you see this, it would be nice if we could just erase. Maybe this little thing does something. So like that. That's still undoing. I'm sorry. I got a lot going on. And now all of a sudden I see that my calculator mirror. Trying to do the whole screen. So now I'm going to iPad. There we go. Sorry about that. Mirroring 360 that I send my iPad through. If it has a glitch for a split second, it may kick back, or Ecamm may kick back. So, my goodness, it's taking everything off the page. Maybe that was a good thing. Now let me try this and that doesn't do anything. Let me take everything off. Painful to have to watch that. I'm sorry. One second. Sorry about that. Not only did you have to watch me backspace, but you also had to watch me answer the phone. That was a lot of fun. Okay, now we're looking at exactly what I started in here to do. And that's to find the mean of this binomial distribution. Well, all I have to do is NP, which is just going to be 5 times 0.25. If you're unsure, if you're like, man, I just can't multiply those, and this is a test. Whoops. 5 times 0.25. Boy, I'm decimal deficient tonight. Equals 1.25. So there's your mean. And then if you wanted to find the variance, which you're going to be tasked to do, you go NPQ. So you take what you got for NP which was 1.25, and you then multiply that by 0.75. There it is. 0.94. We'll just go with 2. There we go. All right, so you found the mean, check, and you found the variance. All right. So let's switch to a screen because I've been working on this screen. I've been trying to make this a little bit different. How about this? Look at that. I've got something running in the background while we work through a problem. Okay. So I've got a surgery success problem up here. A surgical technique is performed on 7 patients. You are told there is a 70% chance of success. Find the probability that the surgery is successful for 5 patients, at least 5, and less than 5. Okay, so I'm going to use CDF here in just a second instead of PDF. But here are the steps for the calculator. Once again, second vars, that brings you to binomial PDF. NPX is the syntax. And you're going to use NPX for exactly 5 patients. That's easy. So in other words, what I'm going to do is I'm going to go second vars, binomial PDF. My N was 7. My probability of success, 0.7. And then for that first value for the random variable x in this discrete distribution is 5. There it is. So 0.318, if you took it out at 3 decimal places, would be the probability of exactly 5 patients. Now you're looking at least 5 patients. Well, at least 5 patients is 5, 6, and 7. So I could go the probability of 5, which we already have, and now go 6. There's enter. Add that. So you got 0.318, I said it was, 0.318 plus 0.247 plus, now I'm going to do it again, second, enter, scroll back, and I'm going to do 7. And I get 0.082. 0.082. So that's 0.647. So I'm on 0.647. I'm just putting this in here for reference, so we've got it up there. So for that section B, selection B, at least 5 patients. So you got at least 5 patients. So you got 5, 6, and 7, with 7 being the top of that chart. So 0.647 is the probability of at least 5 patients. Now, if you're going less than 5 patients, or let me do it this way. Let me go back to what we just did. Second vars, binomial PDF, and I'm going to go 7, 0.7, and then I'm going to go comma, and I'm going to go second parentheses, and I'm going to put 5, 6, 7. Enter. There are 3 that I need. That was 0.317, which is 318, 0.247, and 0.082. Same as I got individually, by the way. No problem there. So now I go here. Now let's look at the second one. 0.647 was the answer to the second one. Less than 5 patients. Well, less than 5 patients is 0, 1, 2, 3, and 4. So we're doing a cumulative addition from 0 to 4. If you use CDF, then you're using a cumulative density function, which is going to run from the lowest value, which is 0, up to wherever you tell it to stop. So second vars, binomial CDF, and I'm going to go um, 7.7. Then I'm going to go comma, and what do I want to take it up to? 4, right? And that's 0.352. So the answer to C is 0.352. Now, at least 5 patients was 5, 6, 7. Less than 5 patients was 0, 1, 2, 3, 4. If you add those two together, you should get a full 1 for this. So if I go 0.353 plus 0.647, I should get 1, and I do. There it is. All right. I think that's where I'm at tonight. I think I feel good with Binomials, if you've reviewed any this week, should be ready. I wanted to go over the calculator. I wanted to go over mean and variance. Now, the standard deviation for any one of these is the same. It has the same mathematical relationship. If you take the square root of the variance, you're going to get the standard deviation. It's the same thing with these discrete distributions, so no change there. So hopefully this helps a little bit. I have a little bit of shorter stream tonight, and I hope it prepares you a little bit. We should have already been prepared for the test, so this stuff is not foreign. Yeah, but there we are. Artemisia, I thank you for coming by. Do you have any questions, any normal distribution questions or anything on binomials? If not, I'm probably going to close out. And if my other students in the class come by, they'll see this on video on demand on YouTube. I also have it on Twitch tonight. For whatever reason, I was going to try to push to 2 as well, in case there was anybody else, but I don't think anybody came on there either. So, Artemisia, if there's no more questions, I think I'm going to close out. And anybody else who sees this, hope it helps a little bit for tomorrow night. And I will close it right there. Thank you.